So hello everyone, welcome to my channel. In this video, I'll talk about a few more aspects of signaling in Indian Railways. I have already made a video on different types of signaling in Indian Railways. I'll put the link in the description so that you can understand what are the different types of signals that are used in a railway station. I have also discussed the block section and how automatic signaling works in block section, what are their aspects, etc. So now what actually I'm going to discuss is how this automatic signaling works. Not exactly the full procedure is not possible to explain in one video. In this video I'll basically tell you how these signals change their aspects. So let's begin with the diagram of that signal which will make. So this is basically the block diagram or the sectional diagram of a block. As you can see, I hope you can see my cursor. This is the track block, and the name block section comes from this thing. This is the block. So how this signaling works is actually, you see, this is a block here, this will extend to this end, and this is a block. This we have the current block diagram that we have right now. So now what happens here is we have a battery which is actually the power source. So what happens is this is the positive end and this is the negative end, as you can see. So as we know, current flows from positive to negative, so I'll begin with the positive one. You see, this positive one goes all the way through this track. Follow my cursor. This track comes here and enters this relay. This is called the relay, and from here it again comes back and it ends at the negative terminal, which completes the circuit. Now what happens is this battery is providing electricity. This battery is providing the current which is passing through this entire circuit, and this circuit is completed. So what this relay is actually doing, the main game of automatic signaling is in this relay. So as you know, when a conductor is wound with a wire, then a magnetic field is generated. This is the basics of electromagnetism. I hope you know. If you don't, you can just check it out. It's easy thing. So basically this relay, this produces a magnetic field which pulls this switch upwards, and as this switch connects upwards, this green signal is illuminated and the signal will show green, which means it's clear, and the loco pilot who sees the signal, actually he can proceed further into the block. So this is the block diagram, or just simply I can say this is the diagram of one track block. We have different such blocks in a block section, between two stations, say however far they are. We have this section, a piece of blocks. This is one block, this is again another block, so it works that way. So now how these blocks are connected together and how these signalings work in tandem, like if the first one is red, then the second one will be yellow, the third one will be double yellow, and the fourth one will be green. So how these things work, that has a different issue, and that is actually controlled by the axle counter, which I will make another video someday. So let me now focus on this one, how this relay signaling works. So this is basically a simple process, like in sections which don't have automatic signaling. For that section, like this is semi-automatic kind of signaling, you can say. This is green and red. This kind of signaling we see in semi-automatic regions. So there only this system is used, but in case of complete automatic signaling, then axle counter will also be needed for the complete automation, because it depends on the next 5 to 6 kilometers, and 4 signals work at tandem in automatic signaling sections. Every 4 signals are, not every 4, basically all the signals are connected together. So that is done through axle counter and this relay system also. So this is when there is no train. So as the driver crosses this area, then this signal is supposed to be red, and unless he crosses this block section, this should remain red. Otherwise an incoming train may come and there might be an end on collision. So how is that achieved? Let's see. This is the situation where there is a train in the track. So what happens is, there is a principle in electricity that current always follows the shortest path. So in order to follow the shortest path, what happens is, as we know, this is the battery, the positive terminal, it goes and it comes in contact with this wheel, and these wheels they are together connected by this axle. So they have found a better path. Now they don't have to go through all this relay and all and create a magnetic field, come back. These things are not required. He has found a shorter path. Now what he will do, he will travel through this axle, come to this wheel, and then from this wheel to this track. And these things are all made of iron, which is a very good conductor of electricity. So these things will again, now it will come through this one, and this will again come here, and the circuit completes here. So as the circuit is completed within this part, the circuit is basically, you can say, it is short circuited. This part of the circuit is not in use, it is being short circuited by the wheels, or I should say through the wheels. The current is passing through the wheels. So what happens is, there is no supply in this relay. So this relay, as you can see, it's said it's de-energized. So when this is de-energized, what happens is, there is no magnetic field. So as there is no magnetic field, there is nothing to pull this switch up. As there is nothing to pull this switch up, so this will come to its normal position, and this is the normal position, as you can see. And in the normal position, this will show a red signal which indicates stop. So any incoming train which tries to enter this block section, which is already occupied by another train, unless this train crosses the entire block and reaches to the next block section, this signal will remain red. And once it crosses the block and reaches another block, this circuit will again have to complete the entire path, and then the relay will be energized, and the signal will again be turned into green, as we have seen in this one. Once the switch goes up, it is energized, and switch goes up and the signal is green. So this is how a typical semi-automatic signal works. We see this in many places. And in case of automatic signaling, there is a special device that is connected to in the tracks, basically in the sides of the tracks, which are called axle counters. They count this axles, the number of axles that are passing over that. So say this is the starting of the block section, and this is the end of the block section. So one axle counter will be here, which means both they come in pairs actually. One is the transmitter, another is the receiver. So one axle counter will be here, another axle counter will be here. So once a train crosses this axle counter, it will start counting the number of axles that have passed over it. Say a train has say 100 axles, for example. So if a train has 100 axles, so if 100 axles have passed over this axle counter, which it will count, once every axle passes, it will increment the count, and it will carry on counting unless all the axles pass through. So once say 100, it has counted 100 axles. So if 100 axles have passed through this axle counter, then equal number of axles have to pass through this axle counter also, because if the train has come in from this side, it will have to go out from this side. Otherwise it will be considered that some coaches are left behind, or maybe the train met with an accident, because there is no other explanation why a train entering a block section with 100 axle will come out with say 90 or 99 even. These both the counts of this ends axle counter and this ends axle counter should be equal. Once they are equal, then it is processed through a multiplexer and signals are given according to that, and that multiplexer only controls the signaling. So that's all for today's video. I hope you enjoyed it. Thank you for watching.